What we were looking at yesterday, everybody, were called geometric sequences. And a geometric sequence is different than an arithmetic because with a geometric, you're multiplying each term by a number to move forward. You're not adding. So with arithmetic, you are adding something each time. And that thing that you're adding is called the common difference. With geometric, you're doing something each time, but what you're doing is you're multiplying by something each time, and that thing that you multiply by is called the common ratio. So that's a significant difference between those. Two types of sequences. You know, with arithmetic, we have a formula. I'm not going to relive the formula up here on the board with you, but with arithmetic, we have that formula for Tn. Tn equals the first term plus n minus 1 times the common difference. With geometric, which is what we're dealing with on this, the general term is the first term multiplied by the common ratio raised to the n minus 1. And when you write this and when you use this formula, it's a good idea to put the r in brackets. And I didn't mention this yesterday, but if you enter this into your calculator, if you if you lack the motivation to actually subtract 1 from n in your head before putting the number in, if you need to actually put 12 minus 1, you need to have it in brackets as well. And I don't mean to be cynical about that, because if you do put it into your calculator for y1, where you just put x where n is, you do need brackets around the x minus 1, right? So that's what we did yesterday. Yesterday was the very basics of this. Today it's going to start to get a little bit more challenging. But does anybody have any questions from any of the practice problems? Take a look at your work, please. Go ahead, Ali. 5C. Okay. So determine a formula for the nth term. And what you are told here, well, I'll ask the question first, not of you, but of the whole class. How many of you understand that to go from the third term to the sixth term would require that you multiply by r and r and r? So those people do not need to visually draw out and look at what I'm about to put on the board. But what I'm going to put on the board is, well, there's the first term, there's the second, third. Now we know the third term is 5. Fourth term we don't know. Fifth term we don't know. Sixth term we do know is 135. So this goes back to what I just said about, multiplying before we even got to this question. You multiply by the common ratio each time you move from one term to the next. So looking at this means I'm going to multiply by r, I'm going to multiply by r, and I'm going to multiply by r. So I always say it this way. We're going to multiply by r 3 times, but that's deceptive because that you might think we're multiplying by 3r. That's not what I mean. I mean we're multiplying by r, by r, by r. So actually what we're doing to go from this term all the way to this term is we're multiplying by r cubed. Now I know that we've talked about this before with arithmetic. And the reason it's 3 is because there are 3 leaps you have to make. Does that make sense? How many of you, though, in the past have said, oh, but it's only going to be 2 because I subtract 1? If that thought's entered your head, that's something different. That's talking about going from the first to some other term. So what does this mean? It means that the third term, which is 5, Just take a peek up there. You can see the third term is 5 in the question. Multiplied by r cubed has to give you 135. So this is the equation that we have to solve. To begin with, to solve this, we can divide both sides of it by 5 and be left with r cubed equals what I'm hoping is 27. 135 divided by 5. $27. So now I need to take the cube root of that. And sooner or later, what has to happen is you need to become familiar with things like perfect cubes. I'm just training you for next year. How many of you know that if r cubed is 27, r must be 3? And the reason those people know that is you've ran into this a number of times. You've multiplied 3 by 3 by 3 and got 27. Or maybe you just figure out that it's 3 times 3 times 3. But, you know, it's like me giving you this equation. Do you really need a calculator to tell me that p is 5? I hope not, because, you know, most of us know 5 squared gives you 25. So after a while, you will understand some perfect cubes. 3 cubed is the number that you cube to get 27. If you are in a particularly not confident mood, which we all get in, you might want to go to your calculator, and if you go to the math menu, there actually is a cube root button. We can take the cube root of 27 and get 3. Now that we know the common ratio is 3, I'm going to take the approach that I took. I can erase all this. I don't really want it anymore. I can take the approach that we took before, which is that with arithmetic, if you want to know anything, if you know the first term and the common difference, you're off and running. You can do it. With geometric, you would have to know the first term and the common ratio. Now we've just determined the common ratio is 3. How do we find the first term? Well, I would suggest the most convenient way is to just tell ourselves that if the common ratio is 3, then when I move left to right in the term list, I multiply by 3. So moving right to left, I divide by 3. So I'm going to divide this by 3. 5 divided by 3 is 5 over 3. I'm not some kind of mathematical wizard to tell you that, because it's 5 over 3. It's 5 divided by 3. That's all. If I divide that by 3 again, I'm going to get 5 over 9. That might require a bit of an explanation. We've got 5 over 3. I'm dividing by 3. But you have learned that when you divide, you can multiply by the reciprocal, and that's where I get 5 nines from. By the way, if you divide by 3, I hope everybody understands if you divide something by 3, you're finding out what a third of it is. So I'm multiplying by a third. Anyway, now I can answer the question. The general term is the first term multiplied by the common ratio raised to the n minus 1. None of these brackets are necessarily given to you in a formula, but they're there. I can go ahead and put things in now. Tn equals 5/3 multiplied by 3 raised to the n minus 1. And again, like I mentioned yesterday, with the geometric general term formula, you can't simplify it. It is what it is. Is that okay? Other questions? Yep. Thank you. My brain slipped a gear there. Right, this gives 5 over 9, which is the first term, and I wrote 5 over 3, my mistake. Good catch. It is definitely 5 over 9, which is T1. Yeah. Any other questions? Okay, so the lesson today, the mathematics isn't going to be that challenging. It's kind of the problem solving and the thinking that might prove challenging for some of you. What we're looking at today is applying geometric sequences. And we're also going to be looking at finding the number of terms in a geometric sequence, but we'll get to that later. There are many things in the real world that follow a geometric sequence or a geometric pattern. Okay. So let's take a look at the first example. A rubber ball is dropped from a height of 4 meters and bounces up to 3/4 of its height after every bounce. So what does that mean? It means if I drop it from this location and it falls, and it's falling a total of 4 meters to the ground, it's going to bounce up, but it will only bounce to 3/4 of the height that it was dropped from. So I would like you to use your mathematical prowess to figure out what 3/4 of 4 is. And I mean, I know the impulse is to grab your calculator, but 1/4 of 4 is 1, 3/4 of 4 is 3. Right? If I have a pizza that I cut into 4s, and I say, what is 3/4 of that? You're going to get 3 of those pieces. So what we end up with here is a height of 3. The ball is going to bounce to approximately this height, and it's going to be 3 meters. And then it falls again, and it bounces, and what I would like you to do is calculate the height, and we can go in decimal form here. That's okay with a word problem. I would like you to find the height that it will bounce to after that bounce. And if my math in my head is correct, I'm getting 2.25. Okay. Oh, see that? I think he's trying to say something. I'm just kidding. Wouldn't that be freaky if it spelled something out? Okay. Get lost. I know you're just a fly, but I don't want to have to kill you. Okay. 2.25? Okay. So, it bounces up and it only goes to 2.25. I'm running out of room here. I would hope everybody knows how we're finding that, but if in case you don't, we're multiplying by 3/4 each time, right? So to go from 4 to 3, you multiply by 3/4. To go to 2.25, you multiply by 3/4. So what we have are the bounce heights forming the terms of a geometric sequence. And the geometric sequence has a common ratio of 3/4. Now comes the tough thinking part. The question is, what will the height of the ball be after 12 bounces? Now, if you look at the sequence I've got there, and I'm going to write it on a new page. I've got 4, 3, 2.25. This is tricky. This is the height after one bounce. It's the second term in the sequence, but that's not the height after the second bounce. Look at your diagram. Here's bounce 1. The height after bounce 1 is actually the second term. You catching my drift here? So we have two options here. One of the options is to use 4 equals the first term. And I want you to hold back on doing any calculations just yet. One of them is to say, well, I'm going to use T1 equals 4, which is the height after no bounces. Right? It hasn't bounced yet. And the common ratio, of course, is 3/4. So I can use my formula Tn equals 4 times 3/4 raised to the n minus 1. Okay? That would be my general formula. But if I want to find the height after the 12th, is it the 12th bounce? Was that the question? Bounce. The question is, what should I use for n? And this isn't a complicated mathematical question, but it's slippery. I'm not going to use 12. 12 will not give me the height after the 12th bounce. How many of you are fairly confident you know the value of n that you're going to have to use to find the height after the 12th bounce? Okay? 13. Because if I go back to this is after 0 bounces and it's the first term. This is after 1 bounce and it's the second term. This would be after 2 bounces and it's the third term. So the term number is 1 more than the bounce number. I don't know if that's what went through your head, but that's what you would need to do. You would need to use n equals 13. Well, I have a suggestion here that I think makes it easier because not everybody is going to be able to process this. Why don't we use for the first term the height after the first bounce? Because if I use for the first term the height after the first bounce, then the 12th term will be the height after the 12th bounce. I don't have that wrinkle, that discrepancy between the bounce number and the term number. So this is how I would recommend solving it. Can you solve it this way on the left? Sure, but we're going to solve it as a group this way. So if we want the height after bounce 12, using this, we find T12. We've set it up so that the bounce number matches the term number, and then that's easier. So what would my general term be here? My first term is 3. My common ratio is 3/4. The general term now is 3 times 3/4 raised to the n minus 1. And what we're going to do is put 12 in here to find the 12th term, because that will be after the 12th bounce. So we'll have Tn equals 3 times 3/4. Let's just write 3/4 as 0.75. We don't want, when you're asked for a question about a measurement as an answer, we typically don't want it as a fraction. We want it as decimal. I think that's fair. Raised to the 12 minus 1, which is 11. But anyway, 3 times 0.75 raised to the 11. I don't need any brackets here because the base of the power, 0.75, is a positive number. You could put brackets if you want, but the answer is 0.13 meters, rounded to 2 decimal places. Remember how the amount of money in my doubling the penny thing, the amount of money exploded very rapidly? Well, the height here is going to drop very rapidly. Remember over here we said you would use n equals 13. And the 13th term would be the height after the 12th bounce. Go ahead and take this and put 13 in for n. So take 4 times 0.75 raised to the 13 minus 1, which is 12. Get the exact same answer. I think some of you might appreciate why you get the same answer. And it's because we're going to have one more on the exponent here, and that extra exponent will turn that 4 into the 3 over here. Because 3/4 of 4 is 3. Any questions with that first example? All right. Number 2, let's decipher this together and see if we can pull out the important math ideas. The amount of asphalt on shingles decreases over time to weathering. Well, yeah, we kind of know that. When you're talking about asphalt shingles, not ceramic roof coverings or anything else, but just regular run-of-the-mill asphalt shingles, the kind that is covered in that granule stuff that's embedded in tar and it runs off. If you ever have to clean out the eaves at your house, you get piles of that gunk that build up. The amount of asphalt on them decreases over time. When the shingles are manufactured, they have 100% asphalt coverage. They're perfectly covered to 100%. But the amount of asphalt decreases by 4% each year. Now, I want you to note that when I say something decreases by 4% each year, I mean the following. Whatever amount it had at the beginning of the year, it's going to lose 4% over the year, and there'll be that much left. And then next time it loses 4%, it's going to lose 4% of that amount that's still there. Not 4% of the original. It's not losing 4% of this every year. It's losing 4% of this to become that. It's losing 4% of this to become that, etc. So if I made a table of values here where I had a year number and I had the percentage remaining, and I put 100% here. Whoops, I put 100% over here. And I put 1 here. Just think about this. Is the percentage remaining 100% after 1 year? That's the percentage remaining at the beginning. So if you set up your sequence this way, n equals 1 will not be after the first year, and n equals 6 will not be after the 6th year. I don't think we want to do this. What you want to think of is this. Even though we don't really like n equals 0 with sequences, that's the beginning. So I would like everybody to figure out what percent will be left after 1 year. It's not a trick question. It's 100%. You lose 4%. I would like you to figure out for me what percent will be left after the 2nd year. And you cannot do this in your head. Well, I can't. It's not simple. You can't just go subtracting 4. It's 4% of that 96 that you lose. So what you need to do is go back to elementary and junior high and remember that 4% of something means 4 divided by 100. Of means times. So 4% of 96 means 0.04 times 96. And this is the percent we've lost. Okay? We've lost that percentage, which means if we started off with 96 and we've lost that amount, the percentage remaining is 92.16. And believe me, you are not going to want to, nor will you need to, do this every time for every question. Let's repeat that one more year. Let's figure out the percentage remaining after an additional year. Well, you would take this and you would find out what 4% of that is, which means we're going to multiply that by 0.04. Whatever you get is the amount you lose, and you're losing it off of 92.16. So the amount you have left is 88.4736. Does it make sense so far? Okay. What I would like you to do, and by the way, we don't really care about anything above that line because we want to talk about the first term, the second term, the third term, etc. And the first term is the percent after 1 year. This is after 2 years. This is after 3 years. And the reason I've set it up that way and ignored the line of the 0 and the 100 is because then things match up. After the first year is n equals 1. After the second year is n equals 2. After the third year is n equals 3. Okay. But I want everybody to find the common ratio. I'm telling you it's geometric. I want you to calculate the common ratio in decimal form. Which means, what do you multiply one term by to get to the next term? And that means you're probably going to have to do some division on your calculator to get the answer to that question. I'm not trying to rush anybody today, but I want to know at this point, how many of you have the answer? How many of you know what R is? How many of you know what R is and you're looking at it going, well, yeah, that makes sense? How many of you know what R is and you already knew that's what it was before you did this calculation? Just a few people. R is found, we can do this together because not everybody has calculated it. I take a term like 88.4736 and I divide by the term before it, which is 92.16. I get 0.96. Let's try taking 92.16 and dividing by the term before it, which is 96. Whoops. 92.16 and dividing by 96.96. I take 96 divided by 100, even though we're kind of ignoring the 100, it's 0.96. Why is it 0.96? Well, look, if you have 100% of something, this is January 1st of the year, or it's the day the shingles were installed. You have 100%, and I lose 4%, that means that this thing has a piece missing. And the amount you've lost is 4%, which means that you have 96% left. If you lose 4%, you keep 96%. So if I tell you, I have something I'm going to sell, I'm a business person, I'm going to sell this computer, and I say it's 4% off, you can either take 4% of the price and subtract it from the price, or, being a smart math person, you can just say, well, then I'm just going to figure out what 96% of that price is, because that's what I'm paying. The 4% is being given to me. I'm paying for the 96%. So from now on, you need to know that. For example, with the very first question in the bouncing ball, I could have said it loses 25% each bounce. Sorry, I forgot one other little explanation, but I'm going to include it now. So if you go from 100% and you lose 25, this is an important idea for Math 30. You get 75%, and the thing that I forgot to mention is percent means divided by 100. So when you take 75 divided by 100, guess what you get? You get 0.75, which is 3/4. So in my example with the shingles, if we multiply by 0.96, it's because we're multiplying by 96%. So our formula is Tn equals T1 times 96 raised to the n minus 1. Whoops. I'm doing too much at once. Your formula is T1 times R to the n minus 1. T1 is 96. R is 0.96. And here's your formula. It's not a tough question once you get it set up. But we've set it up this way so that the numbers match. After the first year, first term. After the third year, third term. So if you want to determine the percentage remaining after 6 years, put 6 in for n. T6 will equal 96 times 0.96 raised to the 6 minus 1, whatever that is. Got about 78% remaining, roughly. Again, everybody, I've put some thought into ignoring the initial value of 100 so that I can avoid more thinking later. If I called this the first term, then I would have to reason out that I would have to use n equals 7 to find the amount left after 6 years. Are you with me on that? Okay, any questions with A? All right, B. So it turns out that the recommendation is as soon as you get below about 45% coverage, you should replace the shingles. I just teach you a little bit about roofing and shingles here. It doesn't matter that the water is still running off your roof. Shingles do more than protect your building from water. They protect it from heat and condensation inside of your roof. So when you see those shingles that are all curling and there's not much asphalt left on, I've heard people who own homes say, it's okay, no, the water's not leaking through. But you go up in their attic and all of the sheeting in the roof is starting to get mold on it and moisture. Just a heads up. One day you'll own your own house, I'm sure. So if it drops below 45%, it's time to call Dick Contracting and get them to put on a new roof or whoever. How many years are the shingles good for? So what this is saying is that when this hits 45%, you better start thinking about replacing the roofing. And what we're going to try to figure out is this. If Tn equals 96 times 0.96 to the n minus 1, we want to solve this equation. Which, oh boy, my Math 30-1s right now don't know how to solve that equation. They won't know for another month or so. You don't know how to algebraically solve that equation. Because the unknown is part of an exponent. So we're going to solve it on our graphing calculator by using the table features. And we've done that. We've used the tables. Yes, we have. Okay, so I'm going to put in, I'm not going to worry about the 45. I'm going to put in for y1 96 times in brackets 0.96 raised to, oh, here's what I was talking about earlier. You need brackets around that exponent because it's x minus 1. And if you don't put brackets around it, it will raise it to the x, and then it will subtract 1 from the whole thing, rather than subtracting 1 from just the exponent. We're going to set up our table to start at 0 and go up by 1 automatically. So this is how your table setup should look when you go second window. I always recommend, although I haven't been doing this lately, double check to make sure you've entered it correctly before you go to your table. I go to my table and I can see, notice that it's matching what I have here. Where is it? It's matching what I have here, that the first term is 96. I don't, I said start at 0 and go up by 1, right? I just did that out of reflex. That's what we always do. But I don't really care about that 0. I'm looking at these percentages. Shingles are still good. I better start putting away a few bucks because I know it won't be long before I have to replace them. Shingles are still good. Shingles are still good. Shingles are still good. Shingles are still good. They're not. So we do have to mix math with common sense here, because you're not going to, let's say you solved that algebraically. And in fact, you know what I'm going to do? I'm going to solve this algebraically. I'm going to figure out for you what the solution to this equation is in decimal form, okay? Don't worry about what I'm doing. Doesn't matter. When you solve that for n, I did something wrong here. What did I do? Never mind. I see what I did. 45 divided by 96. N bracket. What am I doing here? Try that again. Oh, I think I put 96 instead of 0.96. There we go. When you solve this algebraically, if you knew how, you'd get 19.56, okay? And you're taught in most math classes that you want to round answers to the nearest number. If at 19.56 years it hits 45%, who can tell me why I need to record 19 as an answer and not 20? Yeah. Say again? Can't hear you. No. If I understand what you're saying, that's not the reason. Can you repeat that? Why is 19 the answer and not 20? Oh, it doesn't have anything to do with this 0 and the 100, no. Yep. Right, because after 20, it will be less than 45, won't it? Here on a number line is 19. Here is 20. The amount of shingle coverage is going down, and it hits 45% at 19 point something. It doesn't matter what it is. The question was, for how many years is it still good? So how many years of coverage is it better than 45, which means you have to round down no matter what. And by the way, you can see that by looking at your table, right? 19 is good, 20 is not. So the answer to question B is 19 years. But the only way you can do this is to do it on your calculator. Any questions with B? No? How many terms are in this sequence? Can you confirm for me, everybody, that this is geometric? I don't think you can do it just by looking at it. So Kai, can you explain how you're finding out that it's geometric?
The common ratio is 1.5,
so you've taken, correct me if I'm wrong, 92.16 subtract or divided by 6144, and you get 1.5?
Well, I didn't actually.
You saw it was 1.5.
Yeah.
Wow. Anybody else just kind of see it? That's pretty rare. It's good. Uh, is 1.5 correct, you guys? And how many of you are doing it by taking 9216 divided by 6144? And then you take 6144 divided by 4096. You confirm that you multiply by 1.5 each time, which means this is the general term. Tn is the first term multiplied by the common ratio of 1.5 raised to the n minus 1. And what this is like, we've done these problems with arithmetic, is if the term has a value of 531,441, what is n? Because whatever value of n gives that term, that's the value of n that gives the last term. So that must be how many terms there are. So we are trying to solve this. 531,441 equals 4096 times 1.5 to the n minus 1. Now, I hope you understand you can't solve that for n, so you go to your calculator. I also hope you understand, unlike the previous question where we got 19 point something, it was in between, this has to be a natural number for n. You can't get a decimal here for n. So we put in the right-hand side of the equation for y1, and we go hunting around in our table to find out when we hit 531,444. Right there, 13. You know, it's kind of why I told you yesterday, sometimes geometric sequences are easier because you're not expected to do it algebraically, so you just poke around on your calculator until you get the answer. So there are 13 terms. Any questions with number 3? That's it? Is that it? Wow. All right. So if you play your cards right, you should be able to get through all of these problems today and not have to worry about anything for Monday. It's today, day 3. We have a seminar on Monday. So probably, I don't want to do another quiz right away, but probably on Monday, you'll get your first written assignment during seminar. And we will talk about it a little bit during seminar and give you some time to get started on it. But that will be the only class time you get. You'll have to commit your own personal time to getting it completed. And I'm thinking it'll be due Wednesday or Thursday of next week. Okay. Get started on those. I want to clip my recording and get it up online and do a couple of other things, including attendance, and then I'll come around and give you a hand.